My HVAC soldiers out there. All right, let's take a look at the EEV. Now, back in the day, and they still use these a lot, the mechanical expansion valves. You could also have a piston. I still see pistons out there, flow rater, different types of metering device of what we're using to monitor the freon going into the evaporator coils. But right now I've dissected a EEV for you guys so y'all could actually see the inside of one if you haven't. Maybe that'll hopefully help understand what we're doing on a mechanical TXV. When I say mechanical, that's non-EEV. That's what you're going to see, where you see the sensing bulb strapped to the suction line, insulated. That is telling the temperature. We're determining the temperature on that suction line, which goes and sends pressure back to on a spring to open and close that mechanical valve. That's where we check superheat, subcooling, stuff like that. On an EEV, doing the same exact thing, but at a more precise scale. You'll see the EEVs on your higher efficiency units, inverters, all inverters. This EEV that I actually have here is off of a Trane American Standard unit that I've cut open, but they're all going to work the same. Now, they all have sensors. You're going to have a suction line sensor. You're going to have a liquid line sensor. There's a couple of different ohm sensors out there, so I don't have a sensor with me. I wish I did. I was digging through my stuff. I keep a lot of this stuff that we pull off units that are bad, so I could show you how to actually check the ohm rating to know if a sensor is in range, if it's bad or not. But I don't have one, so I will come back to that at a later time and show y'all how to do that. But today, the EEV. All right, so this tube has been cut. We cut this. I've used this several times in training, so I've taken this apart several times and this has been cut. So normally on a unit, you're gonna have your Freon inlet, outlet, or reverse cycle inlet, outlet here, where the Freon's flowing through. Now this is in a case. All this is a magnet. Like I said, you got your suction and your liquid line temperature sensor that is checking the temperature of that line, sending an electrical signal back to the control board, so the control board will tell this EEV what position that it needs to go in, and that's why it's more precise. This happens in pulses, so it's hard to really, it's hard to check the pulse and the voltage on these things. So but here, I cut this open. That's just a metal sleeve. This is a magnet right here, inside here. All right, so this is, I'm gonna unscrew this here. And these threads, so what happens, you got a stepper motor that's always gonna be sitting on your EEV head with the top on it here. So with this, and then this is going to sit down on it. Now this one is too big, and you need to pay attention to this, because I have seen this out in the field before where somebody just stuck something on there, maybe temporarily, and they, for whatever reason, didn't get back, change it, whatever. Your stepper motor has to fit pretty snug on here. There's too much play in this. This is a stepper motor for a EEV that's got a little bigger girth on it than this one. So, but this is just what I had. But it's going to look the exact same. This is going to be a 6-wire setup. You'll see the 6-wire, or you could have a 5-wire setup, but you're going to check them the same way, and they all work the same way. This is a magnetic field in here too. There's a magnet in here. I'm sure you can see it. And if you notice, it's got little like cages in here, and that is separating our magnetic field, and I'll explain that here in a minute. So going back to the EEV, take this off. So the stepper motor sits on top of this, and we're gonna, whatever temperature that those sensors are reading and sending back to our control board, it's gonna tell this EEV to rotate clockwise or counterclockwise. Now, let me get this off here. Here's your pin. That, you see how small that needle is here? And then you see if I can show you what size. I mean, you can see that orifice hole is not very big at all. That's why on an installation, let me see if I can get this in here where y'all can actually see it. I don't know if you can tell right there, that's a very small hole, and especially when this pin is driving back and forth in there. So during the installation process, if they didn't seal up the lines, if they didn't do good practices on the install when they're soldering, if they didn't purge with nitrogen, I'm sure you guys, if you have done some soldering and stuff, if you don't purge with nitrogen, you're going to leave the black flakes. I'm sure you see the flakes that'll go on the outside of the copper. That's going to also happen on the inside of the copper. Well, when the Freon starts going through there, it's gonna break off, and so that can get lodged. I've seen trash get lodged in here, and that's these. I haven't really had too many EEVs fail if good practices were taken during the install process, but it does happen. So yeah, this pin here is just gonna rock back and forth. It's rotating this magnet head on top of here, and we're going to rotate clockwise or counterclockwise in pulses to tell that pin in here to go up or down to allow more Freon into the coil or slow it down on here. So yeah, that's basically all it is, and that orifice is small. So that's why if you guys are in the installation side of it, that's right, it's very imperative on all units to make sure that you're sealing up your copper while you're waiting to get the new unit installed and all that. Just take good practices. In HVAC, with everything starts at the foundation. You can have the best system in the world, but if the installer didn't do good practices on the initial installation, that unit's going to have nothing but problems, never going to work right, doesn't do anything for the customer, and they're spending a lot of money for this stuff. So going back on your stepper motor. All right, I'm going to switch this around because I'm going to have to put this on a bench. Okay, so look at that helmet head kid right there. Yeah, that was me. I was probably about 6 years old there. That was a long time ago. But now getting back to this. So if you want to check your stepper motor, if you got to a unit, you think something's wrong with the EEV, a lot of times if you power down your unit for a second, power it back on, and you're right there by the indoor unit, or these are on the outdoor unit as well too, on heat pumps, you can hear this, or you can hold on to it and you can hear it vibrate on the first startup. And what that's doing is this board needs to know what position that pin's in. So on the first startup, it's going to click and it's going to position that pin up and then down so the board knows what position we're starting in. All right, so that's one way to detect, to know if your stepper motor is actually working, is you'll hear this thing clicking and you can hold on to it. Sometimes you can feel it vibrating. And what that's doing, it's sending the electrical through here, and we're rotating the magnets on the EEV magnet and rotating that pin up or down. So I can actually feel the magnetic field right here holding that in there right now. So, and these are north and south poles on a magnet in here. You can't see it on this, but there are poles inside here as well as here, and that's what helps grip this thing to have it turn while we're underneath this cap here. So if you want to find out, and I'll post this is for Trane and American Standard, but like I said, they all kind of run pretty much the same ohm rating. We're going to check for ohms. So you get your meter set to ohms. If you're not sure what ohms is, just for ease, you're going to look for the horseshoe symbol. I'm going to set mine. I've got different settings on here, so I'm going to set it for the ohms here. Now, on your coil, this is a 6-wire setup, and I already know this because I'm used to working with these, but you're going to have a common. I know on this one right here, these two, if I can grab them, my brown and my red right here are my commons, and they're actually connected in here. So I'm on ohms right now, and this is also very important to get these little needle leads for your meter. These are the ones I normally have on there for checking voltage that comes with it. It comes with your leads, but you can also buy these. These are very thin, very sharp. So be careful. Don't just stick them in your bag, because I've done that and stuck my hand down there and drove it right through my hand before. So very, very sharp. But here, this might be kind of hard for y'all to see everything, but I'm going to check here and here. If I can get them in here. There you go. So I got continuity between, so that's telling me that these two commons are tied together. So and the reason why I'm telling you all this, normally there's going to be 2 wires that you're going to get common to 2 of the wires you're going to read ohms on, and then you might not read ohms on the other 2. And the reason why is because they're separated, because that's where we're sending pulses to rock it back and forth. So it's going to be every other one. Now this one, since my commons are tied together, I'm actually can read ohms reading on all 4 of these other wires here. So what you're going to be looking for is, in most cases, about 46 ohms from common to each one of your wires here inside here. And just to show y'all, see if I can do this. I may not have enough hands to show you. I'm going to go to common here. Go to one here. I'm getting 46.9 ohms, so that's telling me that's good. And if I go to each one, I'm going to get the same thing. On that one, I'm getting 46.8. Go to the next one, 46.4 is what I just saw on the meter. 46.4 right there on that one. And then my last one here, 46.4. Now you could have 45, usually it's about 5% tolerance. So that's telling me that this coil is good. All right, we got continuity, we got the right ohms, so this coil is good. So if I didn't have an ohm reading on from common to one of these here, or a very low reading, that would say that my stepper motor was the problem. Now, also just kind of a little trick sometimes on these, if it's a magnet, now you can't use like a solenoid checker. Solenoid checker is a round magnet that you can slip over the solenoid, see if it'll work. You can't use that because that's a solid round magnet, and we're not going to have that magnetic field to twist this thing. But I have out in the field before took a single magnet and was able to rotate it around, take your stepper motor off, and I've actually unplugged the stepper motor from the board, and I've rolled it around this several times to try to manually drive this EEV open, and it has worked just as temporary measures to get somebody cooling temporarily. Now, I'm not saying it's not going to work every time. I have had it to where I have had it open somehow or another I was told that it shouldn't happen, but I have had it happen on a few units that I get it open, units working temporarily. They call me the next day while we're waiting on a part, and somehow that needle had worked its way back down and closed back shut. So there's the EEV. And like I said, when I get some sensors, I'll do a video to show y'all how to check those sensors. And I also will have those readings that we just took on that. So hopefully that helps y'all better understand it. I'm a visual person. I'll do some videos where I've cut all kinds of parts open because I want to see how it works actually on the inside, and that's what actually has helped me throughout the years. Once I know what the actual part does, then I understand the process a lot better. Don't forget to like, share, follow, all that stuff. Y'all know the drift. So I'd appreciate it if y'all do that for me, and I'll keep the videos coming. So y'all keep going out there.